In this video I will show how you can troubleshoot and repair a car alarm. All you need is an ordinary multimeter and a soldering iron. Some kind of magnifying glass may also come in handy. As a demonstrator I will use a CarGard T70C alarm system, but the procedures shown should be applicable to most car alarms. This alarm has a 16-pin main connector for power, ground and sensors, etc. There are some ports on the side for external modules and a 2 LED status display with an integrated glass break sensor. When I pulled the system from the car, it was completely dead. It didn't react on the remote and there was no light in the status panel. Let's open it up and see what's under the hood. On the top side, the connectors are mounted, and you can see some power supply pads. The radio receiver unit is mounted on a separate PCB. On the back side, most of the components are mounted. Besides the connector pins, it's fairly easy to identify the switches, some driver circuits for external modules, voltage regulator circuit and a microcontroller. I started the troubleshooting by connecting the main voltage and ground pins with alligator clips to a power supply. When probing the data pin on the receiver circuit, I couldn't detect any signal when I pressed the remote. This could mean a faulty receiver circuit, but when probing around on some different positions on the PCB, it turned out that the driver voltage was only about 2 volts. I didn't know what the driver voltage was supposed to be, but many circuits run on at least 5 volts or maybe down to 3.3 volts. However, there are not many circuits that will run good on 2 volts. And apparently something's wrong with the voltage regulation. Sometimes capacitors on the power input can get fried from too high currents. I did have an LCR meter, but when measuring the resistance of a capacitor on the voltage input, it read only 2 kilo ohms, which is a bit low for a capacitor. Now the values may be way off when the component is still mounted in the circuit, so I removed it and measured again. Now it said 2 mega ohms, which seems more reasonable. Apparently it was okay. I then measured the resistance of this resistor, mounted in series directly on the power input. The marking said 10R0, which means 100 ohms, but the measuring said 20 kilo ohms. A resistance that much higher than expected is a pretty sure sign of a broken resistor, even when it's mounted in the circuit. I removed the resistor and replaced it with a new one. Unfortunately, I didn't have a surface-mounted resistor, so just to make sure everything worked, I had to make do with an ordinary through-hole resistor. I hooked the system back up to the power supply again to check the function. The driver voltage was now up to 9 volts, which seems promising. I checked the status panel by pressing the test button. The LEDs were flashing, indicating it's okay. I also probed the radio receiver data pin while pressing the remote, and I could finally detect a signal. I installed the alarm back into the car to check if it worked. Here you can see the status panel flashing, showing that the alarm is alive. First, I programmed the key to the system, just in case. Entering programming mode is done by turning the key 5 times. Rapid flashing of the LEDs indicate it's in programming mode, and then press the button on the remote. Finally, testing to activate the alarm. When I press the remote, the status panel is flashing, indicators lighting up, and doors are locking. It actually works! If you liked this video, you may also like my video on how to repair your keyless entry remote. Thanks for watching!